Hi class, this is Dr. Karsten, and today we are going to do an introduction to Module 6. I am so excited. We are going to get into Module 6, Lesson 1, and my goal is really just to give you an introduction to working with fractions and decimals and how they relate to each other. We're going to be focusing on tenths. So this should be a pretty easy, quick lesson. And again, it's really just an introduction to this topic. We're not going to get a chance to go farther in Module 6 this year, but I want you to be ready for next year. So that's why we're starting here, and we're going to go ahead and give this a go. I also just want to tell you how proud I have been of you in the last few months. You have persevered. You are tenacious and amazing and wonderful, and I love seeing you in Google Classroom or, watching you work and seeing how much you have grown during this time. You really are the most amazing class that anyone could have had, and I can't speak highly enough of all of you. You are just absolutely amazing, and I can't wait to see what wonderful things that you guys do. So with that said, let's jump into this. So I hope you can hear me. I do have the air conditioner going. It's a little noisy, but I did do a sound check and it seemed like everything was okay. So here we go. So we've been working on fractions and adding them and subtracting them and mixed numbers and multiplying and decomposing and composing and all this amazing stuff from Module 5. And you guys are really, really, truly superstars at doing fractions. Now, sometimes we would rather work with decimals instead of fractions. And so we are going to have to understand how to model that and how to show fractions as decimals. So, for example, if I wanted to show 1/10, and we're going to be doing tenths, and I'm going to touch on hundredths, but we're going to be focusing on tenths. If I wanted to show 1/10, the way that I would write that, or the way that I would show that, is by writing it this way in decimal format, and that would be 0.1. Similarly, if I wanted to show 5/10, the way that I would show that is to write 0.5. So I'm going to use a place value chart to show you why this is, just to show you where we are with this. But again, it's just a different way of showing it. It's another way of writing the same thing. So instead of having it in a fraction format, we're going to have it in a decimal format. So let me show you with a place value table or a place value chart. So what you guys are used to seeing is you'll have your place value chart, and you'll have your ones, and you'll have your tens, and you'll have your hundreds. And then we really haven't gone to the right of that. We've kind of just been focusing on, numbers greater than 0. When we've been working with it like this, we have not really gone over to this side. Now, I know in a couple Google Meets, just to help you guys understand when we were adding and subtracting, I did kind of do that a little bit, and you guys are going to be so happy because when you add and subtract using decimals, it's going to be just like you've always done. There's not going to be anything else going on. But anyway, so if I look at this, when I put my fractions in, but I want to write them as a decimal, what happens is there's a decimal right there. So we have our hundreds, our tens, our ones, and then here we're going to have our tenths. And then next to that, and I'm just going to put the hundredths in here to show you hundredths. Oh my goodness, it's such a crazy word to have to write. So what you're going to notice is like when we were doing like fourths and tenths and things like that, we always had the THS on the end. Well, what you should be noticing is that I have the word, if I block this up, I have 10 this or 100 this. So that should help you when you're spelling this, is that you're just putting this word 10 or 100 and you're adding the THS to show that you're to the right of that decimal, that you're dealing with parts or smaller pieces, numbers smaller than 1. So now what you can see is that if I were writing numbers in here, So I don't know, let's do 23 and 4/10. So this would be 23, so you'd have 20, you'd have 2 10s, 3 1s, and then we'd have 4/10. So this would be the same thing, and I'm going to write it down here as saying 4, oops, let me slide this up, 4/10. So I'm not going to write that in there because it's already tenths and I don't want to have 4/10. But anyway, so this would be the same thing though. Having 0.4 or decimal place 4 is the same thing as 4/10. Similarly, let's say that I had a 5 in the hundredths column. That would be like saying 5/100ths. And I could actually put them both together, but I don't want to blow your mind. We're just dealing with what this is, and this would be 3 1s, and this would be 2 10s, which is 20. So I'm just kind of showing you the value here. So this is a real easy thing. If you have a 10 in the denominator, then it's going to be decimal and whatever your numerator is. Let me show you a couple more of these. So let's say that I had 0.3. That's the same thing as 3/10. If I had 7/10, that would be equivalent to, and let me put a 0 in front, that's the better way of doing it. It's just to keep things neat. It's not wrong to have 0.3, but it's the standard way of writing is you put the 0 in front. It's one of my weaknesses. So then I'd have 0.7. So 7/10, 7/10. Same exact value. So it's just a different way of writing it. And again, similarly, and I just want to introduce it to you, if I had, let's say that I had, I don't know, 18/100ths. Well, that one's going to blow your mind, so let's not do that one. Let's say that I had 8/100ths. I'd have 0.08 because I have my ones, my decimal, my tenths, and then my hundredths. And again, we're not going to really be doing this at all. We're going to be focusing on the tenths today, but I did want to introduce that to you so you'll kind of be a little familiar for next year. So again, the other thing I want to show you on this is that everything is going to be the same. It's going to be the mirror image of each other, or symmetrical. Let's use some nice math words, around the ones. So if you think of the ones as like the crease, and if I folded it, it's always going to be the same. I have my ones, then I have my tens and my tenths, my hundreds and my hundredths. Next would be thousands and thousandths, then 10,000s and 10,000, so 10,000s and 10,000ths. So it's going to be always around the one. It's just going to go like this. So if you ever get lost, just orient yourself, find your ones, and know, well, if you know your tens, hundreds, thousands, 10,000s, it's going to be tenths, hundredths, thousands, 10,000s, and so on and so on. So this should be pretty easy to work with. Now, the place that we're really going to see us using this is in measurement. When we're measuring things, especially when we're using metric system, and we're doing things like kilometers or meters and centimeters, that's where you're going to see a lot of using the decimals, and that's actually what we're going to be focusing on shortly when we go into the problem set. But before we do that, let me show you another little thing about this. I just want to say, so let's say that I have 0.3 centimeters plus, let's do an easy one, 0.4 centimeters. So again, this would be 3/10ths of a centimeter, and this would be 4/10ths of a centimeter. And so I'd end up with 7/10ths of a centimeter. And we could do it the other way. 3/10ths. Oh, I'm going to keep messing this up tonight. Plus 4/10ths is equal to 7/10ths. So again, so we'd have 3/10ths plus 4/10ths is 7/10ths, or 3/10ths plus 4/10ths is 7/10ths. Now, just a reminder, what if I had, I don't know, let's do 2/10ths of a centimeter plus 8/10ths of a centimeter. Well, let's look at that with a fraction, and we would have 2/10ths plus 8/10ths is equal to 1 whole, or let's start here. It would be 10/10 of a centimeter, which is equal to 1 whole centimeter. So 0.2 plus 0.8 is going to give us 1 centimeter. Now remember how I said that adding these is actually going to be much easier? Right now you're probably going, whoa, mind blown. How am I going to know to do that? Because let's try stacking and adding them. So if I had started instead and said to you, let's do 0.2 plus 0.8, well, let's pretend those decimals aren't even there. 8 plus, let's pretend like the way we would do it if we were just doing 2 plus 8, you would tell me, oh, well, 2 plus 8 is 10. And I could just write that because I could put that 1 over, regroup it over, right? Same thing happens here. 2 plus 8 is 10. I'm going to put that 1 up here. And now 1 plus nothing is 1. But you have to keep your decimal. So you always have to make sure that your decimal is there. So remember what I said, that it's going to be super easy to add these and subtract these? It's going to be what you know how to do. Let's do one more of these just to show the point. So let's say that you had the problem that was, let's stick to just going to 1 centimeter. Let's say that we had, 0.7 centimeters plus 0.3 centimeters. So again, I could think of this as being 7/10 plus 3/10. So again, this is in the tenths, so it's really 7/10 and 3/10. And we know that 7 plus 3 is 10/10, which is equal to 1 centimeter. Now let's do it and stack them and add them. 0.7 or 7/10 plus 0.3 or 3/10. 7 plus 3 is 10. Make sure you have your decimal. And 1 plus nothing is 1. So this is super duper easy stuff. In fact, you could even add now, a number like 1.4 plus 2.8. So this is 1 and 4/10 plus 2 and 8/10. The decimal is an and. You read it as an and. And I would do 4 plus 8 is 12. And then 1 plus 2 is 3, plus that 1 up there is 4, and you have to remember your decimals, right? Now, let me say this. When I taught in the city, and we were teaching this, I would say to my class, I say decimal, you say line it up. And then I would yell decimal, and they'd yell back, line it up, decimal, line it up. And we would do this in the hallways, we would do it walking outside, we would do it in the classroom. It is really, really, really important that you remember when you are adding or subtracting numbers that have decimals that you line it up. In every single one of these problems, I lined it up. So if I say decimal, I expect to see you or hear you say line it up. All my decimals are lined up. Now, it would probably benefit you that if you were adding some numbers like 0.8, so 8/10 plus 2/10, it would probably benefit you to just write your decimal right away so they're all lined up. And then I could do 2 plus 8 is 10, 1 plus nothing is 1. So you see my decimals are all lined up. It is really important. So let's review really quickly what we've done right here, and then we're going to jump into the problem set. Oh, actually, I would like to do, I'm going to do it in the problem set with you, so it's okay. So one more quick review, which is that if I have a number, if I wanted to show 3/10 as a decimal, I would write 0.3. And similarly, if I had the decimal 0.9, I could write that as 9/10, because that's how we would read this. This is 9/10. So the other thing I want to just again review with you really quickly, one last thing before we jump in there, is that if you're looking at your place value chart, it's symmetrical around the ones. So we have our ones, and then if you look, you see the word 10 and 10. You see the word hundred and hundred? It's just the endings are different. Here we have our tens, our hundreds, our tenths, and our hundredths. Again, this is an introduction for you so that you'll have a little bit of knowledge for next year. So with that said, I want to go over a little bit of the problem set with you before I send you off to do the rest of it. Now, I'm going to have this up as a PDF. You can print it out and then take a picture and share it with me, or upload it as a file to your Google Drive, to the Google Classroom. You can email it to me, or you can work on this in Cami, which is what I'm really going to recommend you do, because for next year you are going to have to be really comfortable, I think, working in Cami for certain things. So I would recommend that you practice it today a little bit. Okay, so this says shade the first 7 units of the tape diagram. So let's do that. So here's my tape diagram, and I'm going to shade 1, 2, 3, 4, 5, 6, 7. So I'm going to shade up to here. And I'm going to do an orange just to make it pop. It's our last day of formal instruction, so let's have some fun. Okay, so now here's what I want you to think about. If this tape diagram represents one whole, let's count how many pieces we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of these is 1/10. Now I could have also figured that out, because you can see that this number line underneath it is going from 0 to 1. So we know that this represents one whole. So it says shade the first 7 units of the tape diagram, which we did. Count by tenths to label the number line using a fraction and a decimal for each point. Circle the decimal that represents the shaded part. Okay, so what they're saying to you is that down here, we want to show how far we've gone on the number line. So what you can see is that when we have 1/10 done here, we've gone 1/10 of the way. So that lines up. You can see that they line up right here. And that's why they put 0.1 or 1/10, and they wrote it as a fraction also. So let's go ahead and let's do some of these. So this was 1/10. If I get to here, I'm at 2/10. So I'm going to write it both as a decimal and as a fraction. And then when I get here, I have 3/10. 1/10, 2/10, 3/10. And another way to write it is 3/10. Now we're going to have 1, 2, 3, 4, or 4/10. And now we're going to have 5/10. And then we're going to have 6/10. And then we're going to have 7/10. And right now you should be saying, wait, Dr. C, look. This is where we're at. We need to circle this one, because it said circle the decimal that represents the shaded part. So here's the decimal that represents the shaded part. So we're at 7/10. Let's go another one. 8/10. 9/10. And then when we get to 1, another way of writing that is to write 10/10. And over here at 0, we could have written 0/10. All right, so that, I know I did that whole one with you, and I do want you to do this one on your work, but I did want to model that. So let's go ahead and let's take a look at what they're asking here. I'm going to do the first one of the next couple problems with you, just to give you a head start, and then there's one that I'm going to let you skip completely. All right. So here it says, write the total amount of water in fraction form and decimal form. Shade the last bottle to show the correct amount. So for this, we just want to be able to model it 2 different ways. So you can see in this first bottle, the water goes past 0.5 or 5/10 liters. It goes up 1 more tenth. So I'd have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So I could write that as 6/10. So that's the fraction form, because here's our line. Or I can write that in decimal form, and there's 6/10. I'm going to let you do this one, so you're going to have to count up your tenths. So, and the 5 is a great check because you can go 1/10, 2/10, 3/10, 4/10, 5/10, and keep going. You're going to write the answer here. Now for this one, where it's saying to us that we have 9/10 of a liter, you're going to have to count up to the 9/10 and draw a line and shade everything under 9/10 liter, and then you're going to have to write it as a fraction. So that's what you're going to do for number 2. You're going to do these two. Let's take a look at number 3. So number 3 says, write the total weight of the food on each scale in fraction form or decimal form. So what they're doing here is they're giving you either the decimal form, like here it says that it's 4/10, or over here they're giving it to you as a fraction where they're telling you that it's 8/10, or over here they're giving it to you on a scale where you're going to have to figure out how many tenths that is. Now I am going to pause here and just say to you, right here, this is 1/10. So what do you think that is? We're going around this way. So if we have 0/10, 1/10, you can figure out what that one is, and then you're going to write it in the fraction format down here. But let's get back to this one. Let's do one of these together. So here you can see they're weighing some broccoli and lettuce, and on the scale it says 4/10 kilograms. So I'm going to go ahead and write that, 4/10 kilograms. So now you're going to have to take this one, convert it, and do the last one in number 3. So let's go ahead and let's take a look at the next page. So on the next page, it says here, write the length of the bug in centimeters. The drawing is not to scale. And that just means that you actually have to read it here. You can't like guess by looking at the bug to see what it is. So here we have a ruler, and we can see that these are centimeters. So when it says cm, it means that when you go from 0 to 1, that's 1 centimeter. So you're going to have to figure out how many tenths of a centimeter is that. And don't tell me it's half a centimeter, because that's not going to help you with the tenths. You really need to figure out the tenths. So you are going to count all these tenths. You're going to go 1, 2, 3, etc., etc. And then you're going to write it as a fraction, and you're going to write it as a decimal. And then it says, how far does the bug need to walk before its nose is at the 1 centimeter mark? So basically they're asking you, how far does it have to go to get to here? So it's this distance right there, from here to here. All right, number 5. Number 5 is probably the only slightly tricky one here. And let me say this, because I'm just doing a quick introduction and I'm not doing a full crazy lesson, even though I love this lesson and I love all these lessons, you don't have to do number 5. I'm going to model a couple of them for you, but I'm going to say 5 is optional. So we're going to say that this one is optional. So here it says, fill in the blank to make the sentence true in both fraction form and decimal form. So here it's saying to you, 8/10 centimeter plus something is going to give you 1 full centimeter. Or I could say 1 centimeter minus 8/10 is going to give me what's missing. And remember that 1 centimeter, if I'm dealing with fractions, could be written as 10/10. It's going to match up that denominator. So if I had 10 pieces minus 8 pieces, I would be left with 2 pieces, or 2/10 centimeters. Because 8 plus 2 is 10, and that would give me 10/10 centimeters. And now that we know that it's 2/10, we could do the same thing over here. Or we could say to ourselves, how many more tenths do I need to get up to the full centimeter? And we're going to have 0.2 centimeters. If you feel like you can do this, go ahead and do 5B and 5C. But if not, it's really okay to skip that one for today. So let's look at number 6. It says match each amount expressed in unit form to its equivalent fraction and decimal forms. So we have unit forms, we have fraction forms, and we have decimal forms. And you can see they did the first one for you. So here it said 3/10. So they looked down until they found 3/10. And then they looked down until they found 3/10. So I'm going to do one with you. Let's do 5/10. So if I had to find 5/10, I'm going to look for one that has a 5 in the numerator, and the denominator is going to have a 10. And right here, that's it, 5/10. So So I'm going to put my line there. So now we have to look for one that's going to say 0.5. So this is 2/10, 6/10, 3/10, and here it is, 5/10. So I can go ahead and draw my line down to the 5/10. And there you have it. That is, in a nutshell, writing tenths, fractions that are known as tenths, into decimals. So that's a pretty easy lesson. Again, I also touched on the hundredths just briefly, mostly to show you the symmetry of place value and how it works. But this was a nice quick introduction for you. I am going to miss you terribly. You have been amazing. And we have a bunch of fun stuff planned for Fun Friday. I have an incredibly fun project planned for you guys next week. So make sure that you check into our Google Classroom next week. You will be very sad and regret it if you do not. Because it's a really, really fun project, group project. We're all going to work on it together. And it'll be something that you'll get to keep forever and ever and ever. All right, so with that said, my friends, my class, I will see you in our Google Classroom tomorrow morning. Have a great night. Have a great day. Have a great summer. Bye, guys.